Hello, I'm doing this video because it's a nice illustration of vector methods applied to geometry that I haven't seen any place else. And the problem is to find the circle through 3 points in space in 3D. All the derivations I've seen were in 2D. So the vectors carry you through the derivation. You don't have to think that much about it, just have a nice picture. Now, this is the circle. This is point R1, R2, and R3 given here. There's point 1, there's point 2, and there's point 3. V1 is the vector from 1 to 2. V2 is the vector from point 1 to 3. Now the normal to the plane is very simple. Simply V1 cross V2 is equal to N. My hand is swollen by I broke my hand a couple places. All right, so that now, and then having N and now having N, we can find the normals to the vector V1 and V2 very simply as N1 is equal to N cross V1 and N2 is equal to N cross V2. Going like that, there's N2. Then we can write the simple relation, obvious relation, that R sub C is equal to V1 over 2 plus alpha times N1, and R sub C is also equal to V2 over 2 plus beta times N2. To solve for either alpha or beta, we can take the dot product with V1 or V2. I just randomly chose V1, which makes V1 dot N1 equal to 0, and then we can solve for beta by as follows. Beta is V1 over 2 dot V1 minus V2 over N2 dot V1, and N2 dot V1, again going back to the illustration which tells us what everything is. N2 is equal to N cross V2, and N is V1 cross V2, so N2 is equal to V1 cross V2 dot V1, and if you do a little vector algebra, you get N2 dot V1 is equal to this term here, so now you have beta, and so now you have R, you have beta, so now you have R sub C, all in terms of the vectors V1 and V2. The algebraic formulas that you apply here, I've written down here. I'm not going to read them off. This should be familiar from vector algebra. All right, now to determine the equation of the circle, what we have is we have the center of the circle, and we have the normal to the circle, and we have the radius of the circle. The center of the circle, R0, is equal to R1, this point right here, R1, plus R sub C, and the distance of any point from the center is R minus R0, and whose absolute value is R, the distance R, and the radius of the circle R is equal to the absolute value of R sub C. And we also have that R minus, that since the N is the normal to the plane of the circle, we also have that R minus R0 dot N is equal to 0. Now I can expand this equation in terms of coordinates to get this equation, which is the equation of a sphere, noted. And in this equation here, expanded in terms of the coordinates, is the equation of a plane. It's equation 2. Now, to get the equation in terms of x, y, and z, I can solve 2 for z and substitute into 1. Then if I do that, I have this equation becomes z. Before I do that, I note that z, I'm sorry, before I do that, I'm going to write this out in the more familiar form. Z is equal to ax plus by plus c, this equation. And this equation becomes ax squared plus by squared plus cxy plus dx plus ey plus f is equal to 0. Now, to to plot the circle, I can assign a value of x and solve this equation for y in terms of x. So I get star for y equal f of x, and then from this equation I get z is equal to g of x, and that, you may recall, is the equation of a circle in space in terms of the parameter x. Just a little illustration here. This equation is the equation of a circle, is the equation of ellipse in the plane xy, and then to get any point on the actual circle, I have point x, then point y. Given x, I solve for y of x, and then I find z as the point on the circle. That's it. Thank you.